Now, the next problem under unit and dimension is this. At what respective values of x, y, z will the dimension of moment be equivalent to mu to s, lu to y, t to z? At what respective values of x, y, z will the dimension of moment be equivalent to this? So what they are trying to tell us is that the dimension for moment is this, but at what point of x, y, z will the dimension of moment be equivalent to this? That's what this is asking of. So what they're trying to tell us is that they're telling us that moment of a force, that the dimension of moment of a force is equal to what? M to x, L to y, then t to z. Okay, the dimension of this is equivalent to that. In some cases, you might see a question, they will tell you that something is equal to something. They will not tell you at what point of this and that is this to that. You understand? So it is very cheap to work on. So the first thing I'm going to do is to get the dimension of moment. If I'm able to get the dimension of moment, then I'll compare it to this. I will now be able to find the value of x, y, and z. As simple as that. So when we talk about moment, so moment of a force is nothing but force times what? Distance. Okay, when we talk about moment of a force, we're talking about the force acting along a particular rod. Okay, we can talk about a straight line or something like a rod that has a pivot at a point. Okay, so the moment about that point is nothing but the force times the distance. Okay, so that's just basically what moment is all about. Okay, so now next thing I'm going to do is that since moment is force times distance, I try to get the dimension of moment. So first of all, what is force? Force is mass times what? Acceleration. Then I still have distance here. So moment is force times distance, while force is mass times acceleration. Then I still have distance, okay, times distance. So which means that moment is mass times acceleration times distance. So mass is measured in kg, acceleration is measured in meter per second squared, then distance is measured in what? Meters. So now, since mass is measured in kg, what is the dimension for mass? The dimension for mass is m. What is the dimension for meters? You know, meters is the unit of length. So the dimension for meters is length. Then what is the dimension for time? Seconds, okay? Time, the dimension for time is t. Okay, this is to the power of 2 because this is s to the power of 2 times. What is the dimension for length? Because meter is the SI unit for length. So the dimension for length is L. So when I expand this, I'm going to have L times L is L squared over T squared. Such a way that this can be the same thing as L to 2, then T raised to power minus 2. Okay, so the dimension for moment is L to 2, T to 2. So I'm going to compare this with the question they gave to me. Okay, they said at what respective values of x, y, z will the dimension of moment be equivalent to this? So if I equate the dimension of moment, which is L to 2, T to minus 2. Okay, this is minus 2, don't forget, okay? If I equate this to M to x, L to y, then T to z. If you can check that this M now has a power 1 because this is just M, so it means M to 1, this is L to 2, T to negative 2 is equivalent to M to x, L to y, then T to z. So if we compare now, find out that M here is M here. So it means that x will now be equal to the power of this M1. L here. What is this? This is y. What is the power of this one here? It is 2. Okay, that is y is 2. Now the next is t and t. This t is z. What is the power of this t here? Minus 2. So when x is 1, y is 2, z is minus 2, then the dimension of moment will be equivalent to this. Now, let me get another question, okay? Assuming you're asked to find, let's say, I'm trying to bring in another question. Find the dimension for momentum. So when we talk about momentum, what is momentum? Mass times what? Velocity. Okay, or force times time. You know, the dimension for momentum and that of impulse, they look similar, the same. Okay, let us find the dimension for momentum and impulse of a force. Okay, impulse. So we know that momentum is what? Mass times what? Velocity. Okay, let us find the dimension here. So this is mass. The unit for mass is kg, and the unit for velocity is meter per what? Seconds. Okay, now as you can see, this is kg times meter over x, because meter per second means meter over x. So kg is the SI unit for mass, that is kilogram. So the dimension is m. Meter is the SI unit for length, so the dimension is L, over x is the SI unit for time, so this is t. So this will give us mlt to negative what? 1, because this t going up. So the dimension for momentum is mlt to negative 1. Okay, let us find that of impulse. Impulse of a force, impulse is equal to force times time. Okay, so what is the formula for force? We know that force means mass times what? Acceleration. Then times, this is time. So remember that force represents force, mass times what? Acceleration, then time. This is time. Okay, so this will now be equal to, what is the SI unit for mass? That is kg. What is the SI unit for acceleration? Acceleration is meter per second squared, times, what is the SI unit for time? Seconds. So as you can see, the dimension for mass is m, the dimension for length is L, over the dimension for second, that is time, it is t to the power 2, times the dimension for time is t. So when we solve this out, we have m, this is L, this is t, this is t, this is t to 1. When this 2 is coming up, minus 2. So we now have mlt to negative 1. As you can see, the dimension for momentum and the dimension for impulse is the same thing. So anytime you're asked to find the dimension of anything, whether the dimension of force, the dimension of couple, the dimension of anything, first thing first, get the formula of that thing. Once you get the formula for that thing, then get their SI unit. Then after getting their SI unit, you can now be able to get their dimension. Okay, very, very important.